Welcome back to Learning with Merit. Today we're going to talk about for loops. Here we have a nice little file pulled up for us. And if we look at this, we're going to look at for loops without lists. And we're going to look at iteration, what that is. We're going to look at Python indentation and code blocks and the rules for that. We're going to look at some for loop syntax, the range constructor, ascending, counting up by ones and multiples. We're going to look at descending, counting down by one and multiples. We're going to look at special things to Python, the for else loop. We're going to look at the for each loop. We're going to look at off by one errors, throwaway variables, nested for loops, and the break, continue, and pass keywords. And that's what we're taking a look at here today in Python. Let's take a look at what iteration is. So if we define iteration, we can look at it as the repetition of a process or a function. And these iterables that we can work with are specific data types that return their values one at a time. And then we can think of iteration as looping or repeating. So that's really what it is when we think about it. We have some iterable types in Python. There are several that we're going to go over here. First is strings, then we have lists, tuples, sets, dictionaries, and then anything that implements the iter method. These are called iterators, and these allow us to loop through them in some way. So when you define your own class, you can define it as an iterator and what that iterator function does. And then of course we have something called generators. Generators are functions that return an iterator. So basically we will be dealing with, especially in the beginning, we're going to be dealing with strings and lists. We'll also be dealing with tuples and that sort of thing, a lot more dictionaries as well. Probably strings, lists, tuples, and dictionaries are going to be the most common that you deal with as a beginner. Now, when we're talking about this, instead of doing something like this, where we have printed and printed and printed and printed, right? It makes a lot more sense to write less code that can do, honestly, a lot more. All I've done is go to 10 here, but imagine if you were going to 1,000 or 10,000 or 100,000, right? We need something that makes it so that I don't have to repeat myself over and over and over. So we're going to try things like this. Here's some while loop iteration. Here we have a while statement where we are taking a number variable here and we're saying start at 1, and then we're going to go until we hit 10, and we're going to print that number out on the same line with a space in between and increase num every time, and we get an output that looks something like this. Or we could do some for loop iteration. So if we did that, we've got for num in range, and what this is right here is called the range constructor. We're going to talk about that in just a minute. But the range constructor is going to create a sequence of numbers that we can go through. In this case, the sequence is from 1 to 10 by ones, so it should be from 1 through 10. And all we're doing is, as we loop, we are printing out each of those numbers. So we get an output of 1 to 10 with a space in between. And then the last one, this is called recursion, and we'll deal with recursion later when we deal specifically with functions. But this is a good example of what recursion might look like, and really all you're looking for here is the part where we call the function inside of itself. So here we have the definition, and here we have where we are calling it inside of itself. And this allows us to do something repetitively. And there are differences between iteration and recursion, and we'll talk more about those whenever we actually do recursion. So those are our basic, repetition types that we can do, while loops and for loops. We're going to talk specifically about while loops today. Next, we're going to look at indentation and code blocks. So in Python, indentation is of course required, and it's going to create blocks of code, and these are groups of statements that we're going to execute together as some sort of unit. Then each indentation level represents a higher level of code structure. So in conditionals, loops, functions, and classes, as we go up or down indentation, we're either getting more specific or less specific, right? You think of these as like scope. The further down you go, the more concentrated the scope, and the higher up you go, the more global the scope. And we look at this, all statements within the same code block must have the same level of indentation. If you change the indentation level, you're going to get a syntax error. And then the end of the block is indicated by a decrease in that indentation level. So let's look at some examples of these. Here's a good example of a conditional. So here what we have is we have our if statement, and then you will notice that I have indented this block right here. This is the start of the block. And then when I unindent the block here, this is the end of that block. And this is going to be similar in all of the ones that we are about to look at. So here's our while loop example. So in the while loop, we have the 4 spaces here, and then unindent to get ourselves out of that while loop block. Same thing with a for loop. We have 4 spaces, and you can see them highlighted right there, 4 spaces, and then unindent. Same thing with functions, 4 spaces and unindent. This is how we indicate where we are at, right? Is this a part of the function? Is it not a part of the function? Is it a part of the for loop? Is it not a part of the for loop? While loop, not a part of the while loop. Here's an example with a class. Again, we have those indentations, and you'll see that I also have this function inside of the class. This is actually technically called a method, and this is the initialize or constructor method for the class, but that's for a later video. But anyway, the idea is you see that I have another indent here before I typed the pass keyword, and that's because we are going down in our hierarchy. Then if we have a nested example down here, we could throw in this. So here we have a function definition, and inside of that we have a for loop, and inside of the for loop we have a while loop, and inside of the while loop we have an if statement. And you will see that each time we have indented more to indicate what level we are at. And all the way down here inside we have a print statement that belongs to this if. A quick note on indentation. So indentation is typically achieved using spaces or tabs, and we don't want to mix spaces and tabs, right? Because this can lead to syntax errors or inconsistent behavior with Python. Now, Python 3 disallows mixing tabs and spaces for indentation in the same source file, and if you're using an error editor like VS Code, you can use the tab key, and this makes spaces not a problem because you can actually set that tabs are meant to be translated into spaces, for example. And so that is an important thing to remember about indentation when we're dealing with Python. We don't want to mix those tabs and space characters because you can cause an issue. Alright, so some for loop syntax. The for keyword defines the start of a for loop, so we're going to use for every time we are going to make a for loop. Then each for loop has a loop variable that we have to define that appears after the for keyword. Then in the for loop, Python is going to use the in keyword after the loop variable, and then this is going to signify that the loop variable will take on each value from the iterable in turn, meaning in line or in order, right? And then a for loop iterates through an iterable type, being placed after the in keyword. So we can actually take a look at what this looks like. We can also remember that the colon symbol is used to indicate the start of a block of code that is about to be repeated. So if we take a look at this, there we go, make that nice and pretty. If we create an iterable object, and here's one we're going to use quite often, it's called the range constructor. We'll talk about that in just a second as well, but this creates an iterable object. And basically it's a sequence of numbers 0 through 4. That's what range 5 is going to do. Now we use the for keyword, then we create a loop variable. Here I've been very generic and called it loop underscore variable, and that is my loop variable. Then I use the in keyword, and here we've passed iterable object, which is just this range or sequence from 0 to 4. And then we've added the colon. This line right here is what we call the loop header or the for loop header. Then we're going to indent 4 spaces to be inside of the loop block, and we're going to repeat whatever the code is. In this case, I just put a string in there to say repeat this code block because we don't know what we're going to do yet. And then we unindent 4 spaces to exit the loop block. Then if we want to look at this a little bit differently, here we can see sort of the blocked grouping. Here, this whole thing is our for loop, and then inside of this is where the actual block is based on indentation. Now, if we come down here and look at an example, here we have for num in range. So my loop variable is num, and range 5, that's going to give me numbers from 0 to 4. and then I'm going to print num, and then I'm going to use the end parameter, keyword parameter here, and set it equal to just a space. So instead of printing out new lines every time, we print out a space between each number. So what I should do is print num in range 0 to 4, so 0, 1, 2, 3, 4. And that is the output that we should get. If I go ahead and run this, what you'll see is I get 0, 1, 2, 3, 4 as well. Let's talk about the range constructor. So the range constructor is going to construct a range object that is an iterable sequence of numbers. So we have a sequence of numbers that we can loop through, and that is what range is going to be used for. So it returns a range of numbers from start to stop plus 1, and that's very important that we know that, because the stop minus 1 is going to determine how we use this range constructor whenever we actually call it. So the range constructor has 3 parameters. It has start, stop, and a step. And then these parameters define the range of numbers that is constructed. So the start is always included in the range. The stop is always excluded. That means the last number in the range is stop minus 1 for ascending ranges or ranges going up, and stop plus 1 for descending ranges, meaning ranges going down. Now, if we keep going here and we look at this, here we have an example. I've created start, stop, and step, and these are just placeholder variables for right now while we look at the syntax. The range constructor has those 3 parameters, and then we are going to go from start to stop minus 1 here. So here we have range, and you'll notice that it says the name of the constructor plus the parentheses after it. And then we have start, stop, and step. Those are the 3 values that we can provide to it. And then here is a good example of the range constructor in use. We have 0 to 11. Now, that doesn't mean we go from 0 to 11. That means we go from 0 to 10 because stop minus 1. And then the step is 1 here. So this returns a range from 0 to 10 going up by 1s or incrementing by 1s. Now, the default start value is 0. This only works for ascending ranges where the step is 1. You can't start at 0 for descending ranges because you can't default to 0 for descending ranges because you have to specify the step. So unless you were to use something like a keyword parameter, you would be stuck with that default. So here we have stop equals, and this is just our placeholder. The range constructor is going to go from start to stop minus 1, and here we just have stop. So if I only provide the stop value, we're going to go from 0 to 11 here, but 0 to 10, right? So this is going to be 0 to 10 by 1s. And then here we have the range with a 6. That's going to go to 0 to 5 by 1s. And then we have range 30. This is going to go from 0 to 29 by 1. So you notice it's always 1 less than the stop. And there's a quick typo right there. Should be 10. 0 to 10 by 1s for that range. Now the default step is 1. This means that ranges by default are ascending, and we're going to specify both the start and the step if we're going to create a descending range. So here we have start and stop. We remember that we're going from start to stop minus 1. If I provide both the start and the stop, it defaults to stepping by 1s. So if I do 5 to 20 here, this actually does 5 to 19 by 1s. 50 to 67, this is going to do 50 to 66 by 1s, and then 100 to 1001, this is a range from 100 to 1000 by 1s. Now here's some other range examples we can take a look at. So start is included, we need to remember that. Our default is 0. Our stop is not included, plus 1 if you're going up or minus 1 if you're going down. And then we have default is 1 when we are dealing with the step. So here we have range 0, 10, 1. This is 0 to 9 by 1s. Then we have range 10, also 0 to 9 by 1s. Range 10, 0, negative 1. This is going from 10 to the number 1 by 1s. Negative 5, 6, and 1. This takes us from negative 5 to 5 by 1s. Then we have 5, negative 6, negative 1. This takes us from 5 to negative 5 by 1s. Now we're going to look at some ascending looping or ascending ranges, right? We're going to count up by one and by multiples. So let's look at the general syntax for counting with our for loops. So we're going to use the for keyword. Then we're going to create a loop variable. In this case, it's called number. Then we're going to use the in keyword, and we're going to give it an iterable object. In this case, it is a range constructor that returns an iterable object. In this case, a range object. And then this, of course, is called our for loop header. Then we have the three variables, start, stop, and step. And then inside of this, you'll notice that I have indented 4 spaces. We're going to type number for the variable we want to print out. In this case, we're going to print out whatever number we're at. And then this is the end keyword parameter for the print function call, and I am just changing it from its normal new line character to a space so that when we do this, everything will be spaced out instead of on new lines. So from 0 to positive by ones, if we're going to go from 0 to a positive value by ones, here's an example, 0 to 10. Here we could just use the default values, so we're going to go from 0 to 10, and then our start is 0, our default is stop plus 1, and then our default step, of course, is 1. And then we are going to print number and end with a space, and here's our output. We end up with 0 to 10. And then we could also do it this way. We could do 0, 11, and 1 like that, and it's the same thing as what we're doing up here, and again we get the same output. Remember, our stop value is not included, so to go to 10 we have to use 11 as our stop value. Let's go to 0 to positive by some multiple value. So let's go to 0 to 10 by 3. So number in range, our start is 0, our stop is 11, and our step is 3. We print that out, we get 0, 3, 6, and 9. And what you'll notice is it doesn't include 10 just because I wanted to go to 10, right? Because I'm stepping by 3s, once I get to 9, and then I add 3 to 9, I actually go to 12, which is more than the stop value, so we stop. Let's go from 1 to some positive value. Again, pretty simple, 1 to 5. So here we have for number in range, 1 and 6. Remember, the stop value is not included, so we've got that. Now we've got print number. We got 1, 2, 3, 4, 5 there. So remember, we're starting at 1, makes perfect sense, ending with 6, which means we actually include 6 minus 1, which in this case would be 5, all the way from 0 or 1 to 5. We could also use, instead of using the default step, we could specify the step, although we do not have to, and we would get the same thing. Then what we have here is we've got from 1 to positive by multiples, so you can change your step value to multiples. In this case, 1 to 6 by 2s. This actually takes us from 1 to 5 by 2, so we get 1, 3, and 5. Then from a positive to a positive value, so we've got number in range 70 to 81. This is default step of 1. And then we have print number, so this takes us 70, 71, 72, 73, 74, all the way up to 80 because 81 minus 1. Then for number in range, we got 70 to 81 by 1s. This does the exact same thing as what this one does up here. We get the exact same output. Positive and positive by some multiple value. So what we've got here is instead of going by 1s, we're now going to specify our multiple value. So 70 to 101 by 5s. This will actually take us to 100 instead of 101. And we print that out. We get 70, 75, 80, 85, 90, 95, and 100. If we're going to go from a negative to a negative by 1s, here we have negative 35, negative 24. And you'll see that the output for this takes us to negative 25. Now, negatives make it kind of weird for us because we're not used to thinking in negatives all of the time, but negative 35 looks like it's going down, but it's actually getting closer to 0, and we end up with negative 25 right there instead of negative 23, which you might have made that mistake. Here again, we can specify the value instead of just the default. They're the same thing in this case, so we end up with the same output values. Negative, negative by multiples. Again, we're going to go negative to a negative value by a larger than 1 value we have to specify. So this takes us from 100 to negative 10 by tens. Right? And since we're going up, meaning getting closer to 0, they are using a positive step value. Negative to positive by 1. So here we have negative 5 to 6. This will take us from negative 5 to 5 in our output. And then if we have the same thing, but we've specified the step value instead of leaving it default. Then negative to positive by multiples. So if we look at this, we've got negative 5 to 6 by 4. And what we end up with is an output of negative 5, negative 1, 3. And of course, we never get to 5 because 3 plus 4 is going to give us to 7, and that stops the loop. Now we're going to do some descending values, so counting down by 1 and by multiples. So if we need to go from a positive value to 0 by 1s, here we have an example of 10 to 0, so we have a range of 10, minus 1, and minus 1. So that means we're going to start at 10, we're going to end at 0, and we're going to go down by 1s, and that is what our output looks like. Starting at 10, we're going to stop at 0, and we went down by 1s. Now, if we're looking at positive to 0 by multiple value, we're just going to change our step. So we're going to start at 10, end at 0, and step by minus 3 every time. And what we should get is 10, 7, 4, 1, and 0. Then if we're going from positive to positive by 1s, we're going to do an example here of 40 to 50. So here we've got, 50 to 40. We've got 50 to 39 here, which will take us to 40, and then minus 1. Again, we have to specify the minus 1 because the default is actually plus 1. If we're going down, we have to specify what we're doing there. And we get an output of 50 going down by 1s till we actually get to 40. Then here, if we're going to count from 100 to 50 by 5s, so we're going down, we've got 100, we stop at 49 because we want to include 50, and then minus 5. So print, and our output will take us all the way to 50 by 5s. Then here we have from 0 to negative by 1, so we are going to go from 0 to negative 10 by 1. So if we look at this, we start at 0, we're going all the way to negative 10. We got to do negative 11 so that we can actually get negative 10 in there, and then minus 1 as we go. Then if we want to do 0 to some negative value by a multiple, then what we do is here we have negative 100 to, 0 to negative 100 by 20s. And of course, we're going to do our stop value is negative 101. And we get 0, negative 20, negative 40, negative 60, negative 80, and negative 100. Going from a positive value to a negative value by 1s, here we've got 5, negative 6, so that we can actually get to 5. So we're going from 5 to negative 5 by 1s. And here we see we go from 5 to negative 5. Then positive to negative by a multiple value. So here we've got 100 to negative 100 by 50s. So we're going to start at 100. We're going to stop at negative 101, meaning stop at negative 100. And then negative 50 is our step. And so we get 100, 50, 0, negative 50, and 100 as our output. Then negative to negative by some by ones. Looking at this, we've got negative 85 to negative 96, which actually takes us to negative 95, minus 1 each time. Then by multiples, we can look at this. We can say, okay, negative 200, negative 1501, which actually gets us to negative 1500, and then by minus 100 each time. Now we'll look at something special to Python, something called the for else. So a for loop can include an else block in Python. The else block is executed when that for loop ends. So if we look at this, we've got for number in range. This is going to take us from 1 to 10 by 1s, and then we will print out the number with a space in between each number, else we'll print done printing. So what this will look like is our output will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then it will print done printing at the end. So the else block is executed after the for loop ends for whatever reason. For each loops. So for loops can also be used to directly loop through what we call iterable types. A for each loop iterates through the elements of an iterable. So let's take a look at this. Here we have some iterable. We're just using this as a placeholder. Our syntax looks like this. We do for our loop variable in iterable. Then this is our code block to execute. And then iterables are something that can be repeated through. For example, strings, lists, tuples, sets, dictionaries, etc. These are all iterable types. So let's look at some examples of these. Here we have a string that contains all of the lowercase letters of the alphabet. If we do for character in string and then print each character with a space, we get the alphabet with a space in between. So each character gets printed with a space in between. We don't just have to do strings though, we can also do lists. So here we have a list of the iterable types, and then an element does not represent an index, but the actual element. In this case, list, tuple, set, dictionary, iterators, these are the elements of list 1D. The indexes would be 0, 1, 2, 3, and 4. So we're not representing indexes here when we do for each loops. So for element, this is representing the actual element, not an index. In list 1D, we're going to print that element with a space, and we get each of these items printed with a space in between them. Something similar is going to happen if we use a tuple. So a tuple is really not that much different than the one that we just did. Element in tuple, print element, we get the same output in this case because I use the same values. The only difference is this is a tuple and that was a list. We could do a set as well, and the set is going to have the same values that I gave our list and tuple. And element in set 1D, print element. The only difference is the output order will vary with a set. So a set is not an ordered collection. And so what will happen is that every time you print it out, you may result in it may result in a different order of it printing out. But here's let's assume that it was ordered whenever we printed it out, just so happened to be that way. This is what it might look like. Then maybe we have a dictionary. So I just have a dictionary where I used the values from my list as keys and then just gave them all a value of none. And then let's say that I want to print out the keys of the dictionary. So I do for key in dictionary.keys like this and print key, and it prints out all of the keys in my dictionary. And then here's a practical example. So summing a list of integers. So if I create a list of nums like this, here's my list of integers, 1, 2, 3, 4, 5. And then I create a variable called sum, set it equal to 0. This is how I can begin. Then I do a for loop for num in nums. So for each number in this list nums, we're going to take the current sum and add num to it, and then set sum to that new value. So basically what we do is we say 0 plus num, which is 1, and then sum equals that new value. So sum is now 1. And then we do sum plus num. Num is now 2. So 1 plus 2 is 3, so sum is now 3. And then we do sum plus equals num. Well, num is now 3. We do 3 plus 3. That gives us 6. So sum is now 6. And then we do sum plus equals num. Num is now 4. 6 plus 4 is 10. So sum is now 10. Then we do sum plus equals num. Num is now 5. 10 plus 5 is 15. Sum is now 15. And then finally, outside of the for loop, you'll notice I've unindented here. We do print sum, and that will give us output of 15. And that is how we can use a for loop like this with a for each loop to sum a list of integers. Off by one errors. So off by one errors occur when a loop iterates one too many or one too few times. And this is typically due to an incorrect indexing or boundary condition. Now what that means is that typically we as the programmer have made some mistake. Either we have asked the loop to occur one more time than we need it to, or one fewer time than we need it to. And it's one of the first errors that can be kind of irritating to catch, because sometimes it doesn't actually throw any errors or raise any errors in Python. So suppose we want to print numbers from 1 to 5, but we mistakenly use range 6, which includes the 0. We've actually included a value we did not intend to. So for I in range 6, we print I, and what we would get out is from 0 to 5, which is not what we intended. This is perfectly valid and acceptable Python code. In fact, if I run it, what you see is it does 0 to 5 just like that, but it's not what we intended. So this can be one of the first errors that can be kind of irritating. Of course, you're just off by 1 there. Let's talk about the throwaway variable, which is just an underscore. Sometimes we don't actually need our loop variable, but we still need that variable to exist. So in order to take up as little as possible in our programming, we use an underscore as our throwaway or unused variable. So here we don't actually need to use this, so we're going to do for underscore in range 5, and then we're just going to print looping. And you'll notice how we haven't used this variable at all, so we don't actually need it. We just want to do something repetitively. In this case, we want to do something 5 times. 0 to 4 is 5 times, and so as we go through this range here, we'll print looping, and this is what our output looks like. And so since there's really no reason for us to use this variable, we just use an underscore, and it is our throwaway variable. Now let's talk about nested for loops. So when we place one for loop inside of another, this creates a nested for loop. The inner for loop fully executes for every one iteration of the outer for loop. So if we take a look at this, let's look at our basic syntax. Here we have for variable 1 in range. We indent our 4 spaces, and then inside of that we place a second for loop. Right? This inner for loop is going to do all of its loops every single time the outer loop loops once. All right, and so this is sort of the power of nested for loops. It's also sort of the downfall of nested for loops. You eventually make really, really slow programs the more and more and more that you have a nested loop. So here we have our outer loop, and then inside of that, our inner loop. And remember that the inner loop is going to execute all the way for each one iteration of the outer loop. Here's some example uses. So let's say that we want to repeat some loop thing that we do 3 times. So we're going to repeat this 3 times. And what we're going to do is we're going to count from 0 to 4 by ones. And this will be repeated 3 times. And then I add this little print statement right here, which you'll notice is not inside of the inner for loop. It's actually technically inside of the outer for loop. This is just a formatter output. So if we look at our output, we'll get 0 through 4 3 times. Same thing here. We're going to repeat something 2 times. We're going to count from 0 to 100 by 20s. And again, we add that print for added effect in our formatting, and we get 0 to 100 twice. Next, we're going to repeat something 4 times. And then what we have is we have from 5 to -5 by ones. Again, that print statement for format, and we end up with counting from 5 to -5 5 times. Last little example here, 4 times, we're going to repeat something, and then what we have is 20 to 9 by -2s. What this does is it takes us from 20 to 10 by -2, and we end up with that 4 times, and so we get 20 to 10 4 times. We're going to talk about the break and continue and pass keywords in Python. So the break statement in Python is used to exit or break out of a loop prematurely. So if we use this with like a while loop or a for loop, we can use this to skip some code and stop the loop. So if we look at this, we've got for in range, and then we've got a for loop nested inside of our outer for loop there. Then we've got an if statement checking, and then we've got a print at a break. Then after that, we have an else with a print inside of it. So if we reach this point right here, so this if becomes true, we print, and then we break. That means we skip all the rest of this, and we break out of this loop. It doesn't mean we break out of this loop, but it does mean that we break out of the innermost loop. And what that does is it allows us to skip all of the rest of the loops in this execution and start a new iteration of that one. Or if there's only one loop, we completely end the loop there. So that's what the break statement is good for, is telling us to stop the loop prematurely. And that's very useful because that means you don't have to continue looping. Now the continue keyword is a little bit different. It's similar to break, but what it's going to do, it allows us to skip the rest of the code for a current iteration or for the current loop and go on to the next one. So here's an example with that. So we have for x in range 50, so we're doing 0 to 49, and we're checking if x is divisible by 7 here. And if it is, we're going to continue. So basically, we're going to skip all of the values that are divisible by 7. And if it's not divisible by 7, we're going to print the value out. So we're going to go all the way to 50, skipping all of the values divisible by 7. And that's what continue is good for. It skips that and goes to the next iteration. And then pass is perhaps the simplest of them all. It's just a keyword that is used to be a placeholder and prevent syntax errors. And this is really useful if you want to give little examples without a lot of code, or you're not really sure what you're going to put there yet, but you don't want to see all of the errors that keep popping up with it. So if we look at that, we can say for num in range 100, and then just pass. And then even though I'm not really doing anything here, I don't have to deal with any syntax errors.